Hi everyone, my name is Tomek. I'm a freelance full-stack developer, and I'm going to talk about spreadsheet-like programming in JavaScript with xcell. In my first job, we were porting a MS-DOS accounting software to Windows 98. One of the assignments was to create interactive WYSIWYG forms for tax return purposes. It looked more or less like that. It actually still looks like that in 2018. This form would be the active form. The yellow fields would be filled by the user, and all the other fields would automatically recalculate themselves. And eventually, the user would print that and send to IRS. A few years back, in 2013, as a member of a small team, I was hired to build a payroll system by an HR company. And they didn't trust us very much, and to see if we are even capable of understanding the requirements and the complicated rules of calculating the payroll, they asked us first to build this payroll calculator where they would just test their corner cases with. So we just set up this simple website for them, and on the left-hand side you would see this never-ending form that they would fill with these parameters. Somewhere down there, probably on the other floor, would be the submit button that would send everything to the backend. We would crunch the data and send back the response, which we would display on the right-hand side, hoping everything is fine. And writing both programs was very hard. We had to implement tons of rules that are defined by the law. And these rules are constantly changing, and often a few times during a year, and our software had to adapt. At the heart of these programs, usually there will be like one gigantic function or method which would take all the parameters, transform them, and then return another universe. And it was very hard to keep the whole logic of the application in your head, and it was hard to maintain it. And those central methods just kept growing, and even though we were trying to keep things dry and follow the single responsibility principles, we would usually end up with code resembling phone cables in Bangkok. And for some reason, it felt more natural to design this calculation in spreadsheets than in a programming language like Pascal, like the first app, Ruby, or JavaScript. In fact, the HR employees, they would bring their test cases in spreadsheets, and they were not programmers. And we would sometimes use these spreadsheets as blueprint for our computations. But once we try to transfer them into our programming language, we realized that we were losing something in this translation. And I think it is because a spreadsheet program is not organized around time, like sequences of instructions, like what to do after what to do, like this control flow programming language that we're using every day, but as a spatial relationship. Right? This is how you create a program in a spreadsheet. Right? You say just the cell C1 just equals this cell over here plus this cell over there, like in a space. And spreadsheet just makes sure it always is true. It magically recalculates the spreadsheet for you whenever anything changes. You don't have to worry if the value ever becomes stale. And in our favorite sequential languages, things don't work this way, right? If we define our two variables, A and B, and the third one that depends on them, and then we change A to something else, the variable C will still hold the previous value, 13. Right? If you want C to equal something else, like 42 in this case, we have to go and explicitly change this value to this new value. This is how imperative programming works. And a spreadsheet, on the other hand, is an example of cell-based data flow programming. And here's what Wikipedia says about data flow programming. And that this is a programming paradigm that models a program as a directed graph of data flowing between operations. And this idea of a directed graph of data flowing between operations seemed to me as something that should not be very hard to implement in any any language. I was kind of expecting that such libraries would actually exist. And I look at the functional reactive solutions in JavaScript like RxJS or MoX, and what I found was not quite what I wanted. I was looking for a simple library that I can express simply that this cell depends on these cells, and this is the formula that you need to use to calculate the value. So I haven't found anything that I was satisfied with, so I decided to create such library myself, and I named it xcell. And using WDD, which is driven development, I came up with a simple API to describe how I would like to define my graph data and the operations. Right here, this is in action. Here we have three cells, A, B, and C. A and B are like these cells in the spreadsheet where you just input the values, right? Like a text or a string or a date, right? The third one, C, this one depends, and we see this explicitly on the other two, and it uses a second argument as a function to use to update the internal value. This is the function. So whenever any of the dependencies change, for example, A value, we set the value here, our C value will automatically always be updated. It will always synchronously be updated. So there will be no situation in our program that this value will be out of date. I'm going to show you a little bit of a demo here. And this is how I do it. Okay, I'm here. Now I swipe. Bang. Cool. This is a very handy application that I created for myself to calculate the actual price of the pizza in a restaurant in North America, which takes 3 parameters, actually. It takes the price in the menu, the tax percent, which is most of the time constant, at least when you're in this one state, and then you have the tip percent. And yeah, so the whole calculation depends on these 3 variables, right? So whenever we change something, the whole calculation happens, and this application doesn't use any JavaScript framework. It's just plain HTML with a little bit of our xcell. But once I think that the cutest part of this library is that once you can define your data as a graph, you can actually see it as a graph. And I'm going to show you this, right? So this is how this application, how these things are connected between each other, right? We clearly see in a spatial situation how these cells depend on each other. And we actually can see how they change when we change the values of a program, and we see when we change the tip percent, only that branch of the graph changes. We don't have to calculate the tax or the gross whenever we change it, right? And this is more or less, I'm not sure if this is visible. Maybe I will increase font here. Okay, so this is how the program looks like. Here we are creating our cells, and later we just connect the inputs to the inputs and outputs to the outputs, right? So our cells is just like a bag, and like a bag of objects. And here is the meat of the program, which is this definition of the graph of data and the operations that flow through it. So first we have our 3 variables that don't depend on any other cells. They just take the default parameters passed to this function. And tax in the line 32 is our first cell that depends on menu price and tax percent that is above. And it uses the function here to calculate its value. Later we have gross, which depends on price, on menu price and tax, and just uses our old friend add. And then we have the tips cell that depends on gross and tip percent. It uses similar calculation as the other one. And at the end, we have total, and which is also dependent on two others, and we return our cells and connect this to our application. So this is more or less how the thing works. And yeah, I wanted to say that xcell doesn't introduce a bunch of new concepts, right? I'm not changing how the objects internally work in JavaScript. I'm just using simple arrays to define my dependencies. I use simple functions as pure as possible to define my operations on the data. And what else? And one thing that I forgot to mention during the demo is that the cells are event emitters itself, so they emit a change event, so you can actually connect it somewhere and have your UI updated. And another thing is that it can be used on the front end, on the back end. You can use it with any JS framework or without any JS framework, like in my demo. You can even try to use it as your state management solution in your application when you have something so simple as this form to implement, or maybe something more complicated. I actually built only one quite involved application with it, which was calculating like a mortgage plan, which used around, for 30 years, it used around 2,500 cells, so it's quite heavy, but it still refreshes the whole DOM on my poor old computer quite vibrantly, so it's quite performant. And it's definitely a very young library. It's not probably not production ready. So if you're curious and you would like to see how it works, maybe you can have a look, and maybe you can help me to improve it and make it better, right? So that's basically it. Thank you very much.